So the first gas law that we're going to look at is actually known as the combined gas law. So combined gas law means, well, we're probably combining several laws. We're actually going to look at 4 other laws. This one is all 4 laws combined. And this overall law here will help you learn the other laws, and I'll show that to you at the end. Okay, so first off, we need to know what the letters stand for. Of course, P is going to stand for pressure. We've got 1 and 2, so we could use I's and F's, initial, final, but in the gas laws we usually use 1, 2. So the pressure in the beginning, pressure in the end, volume in the beginning, volume in the end. N is going to stand for number of moles of gases, so moles hasn't gone away for us. And T is going to be temperature, and temperature is going to have to be in Kelvin. So it must be in Kelvin. So this is our combined gas law, and we're going to do an example of the combined gas law. All right. So it says we have a 2-mole sample of hydrogen gas has a volume of 65 milliliters, a pressure of 0.992 atmospheres, and a temperature of 16 degrees. What volume will the hydrogen occupy? So if you can see, we're going to be decreasing the pressure here, and we're actually increasing the temperature. So we're changing more than one variable. You always use the combined gas law if you're making more than one change to the gas. Okay, so let's write down, we've got 2 moles, so that's N, and so I've got a little chart here just to kind of keep us organized. We've got moles of hydrogen. And then it says we have a volume of, so that's our beginning volume. And you've got a pressure of, ATM is our, even if it didn't say pressure, you need to realize that ATM is a pressure. And then a temperature of 16 degrees. So when we get ready to put it in, if you want to put it in this little chart format, I would say never put it in Celsius, because you're going to forget to change it. So always add that 273 before using it, because you have to have it in Kelvin. So that's 298 Kelvin. All right, over here it says, well, what volume? So I'm looking for volume. Will the hydrogen gas occupy? So we're changing this pressure. And we've got 25 degrees. And so we add that 273, and so you get that 298 Kelvin. And it doesn't say that it says assume that the container is sealed, and what that means is our moles didn't change. It stayed the same. We didn't let more gas in or any more gas out, so the moles didn't change. In fact, a lot of times your moles don't change in these problems. So the original formula looks like this: P1V1 over N1T1 equals P2V2 N2 T2. But because the moles don't change, anytime something doesn't change, they're staying the same, you can just take them out of the equation altogether. So if it doesn't change, you can just take it out. Makes it a little bit simpler there. All right, so here we go. We're just going to fill in some numbers here. So our pressure was 0.992 atmospheres, our volume was 65 milliliters, and our beginning temperature was 289 Kelvin. All right, our P2 was 0.948 atmospheres. Our volume is, we don't know. That's our X. If you prefer X, use X. And then we got 298. Now, I honestly do not care how you do your algebra. Some students, you can get this side and do this and then divide. I do not care as long as you get the correct answer. But I'm going to just tell you, some of you do struggle a little bit with algebra. And if you do struggle with algebra, here's just maybe a help for you. If you will find your x's here, if I do some cross multiplication, This is anytime you've got fractions, this is an easier way to do it. I can multiply these three numbers that don't have my x, and I'll end up dividing by these two numbers. So essentially what we would do in our calculator, just to make it easy, is 0.992, and we would multiply that by 65, we would multiply that by 298, and then you could tell your now you don't have to do it this way. You could then tell your calculator divide by 289. This is going to be the ones with x, and then you would divide by 0.948. So I multiplied the three that don't have the variable, and I divided by each of those one at a time. I'm lazy. I don't want to have to worry about parentheses or anything like that. You can get your answer and you can check it by plugging it back in. But we'll do three significant digits, and so our answer would be 70.1 milliliters. So that is our answer. Now again, that is not the way you have to do your algebra. That's just a way if you struggle a little bit with the algebra. Multiply, cross multiply the three numbers that don't have the variable and divide by the two numbers that do. All right, on to our next law.